worked around the world, but effectively he's been involved in salt for about 40 years. And he set up his own company in 2003, Salt Partners. I think he's very qualified to give us a very authoritative overview of the endeavours that are being made to provide salt ever more efficiently to industry.
Well, Mr. Chairman, ladies and gentlemen, I'm very glad and very thankful to the organizers to give me the opportunity to talk to you about salt. Salt being the being the only raw material to make caustic and chlorine, and together with electricity to split the salt and produce our products. What I would like to share with you is a look from the bird's eye view on some of the world's largest salt works in the world, and why we have chosen this. I will come back to that. They are producing together about 12 million tons of salt per annum and are supplying the world with this raw material. We have done this overview together with my wife and with my daughter, who was shooting the pictures. Now, for this the purpose of this presentation, I have taken the pictures showing the salt stockpiles in the major salt producing companies. So here we have Shark Bay. They are nearest to Perth, where we started, and you can see the size of the stockpile, and you can see that the stockpile is about half full. That was in 2009, and this is how it looks today. It's not a very good picture, but it doesn't show. It shows that the situation has not changed very much. This is a stockpile with a capacity of about 1.5 million tons here at Lake McLeod, and you can see that it is almost empty. Salt is only here, and here there is a tiny little heap of salt, and the whole rest of the stockpile, this area is empty. The situation has not changed much. This is from 2013. We can see that there is salt here, there is a rest of salt here, here is a small heap being produced. Again, approximately perhaps 20% of the stockpile is full. This is a stockpile of the Onslow salt works that was built in the late 90s by AkzoNobel, and it shows salt only here. Here, this is a little heap of salt of about 1,000 tons out of 500,000 tons of the total capacity of the stockpile. And this is in 2013. Here is some salt, here is some salt, the rest is empty. In 2009, the reason for the low salt stock or zero salt stock at Onslow was a flood, and the flood was caused by the flood caused a break of the dikes here, here, and here, and the brine flew out of the first brine pond. This was caused by Hurricane Cyclone Dominic, about 1 week before he flew over this salt works. I will come back to the reason and to the why I'm talking about it later on. This stockpile had a capacity of about 2 million tons of salt per annum, and it was used to dry the salt and store the salt. It was replaced with a stockpile on the way of the salt from the washing plant, from the new washing plant to the delivery of the salt, and again it shows only about 1/3 of the stockpile being actually holding salt. And here also the situation in 2013 has not changed much. We can see a stockpile here, a small stock here, and a little heap beginning to fill this empty half of the stockpile. So we can say that the situation has not changed. This is the delivery stockpile at Dampier. Approximately, it was estimated approximately 40% full, and this is the latest picture, again showing approximately the same situation. Port Hedland was about 60% full in 2009, and is approximately 40% full in 2013. Now, what does it mean? Here we have a calculation of the overall stockpiling capacity of these major Australian saltworks. The design capacity is approximately 6 to 7 million tons, and we have seen that they were holding about 1.3 million tons. 20% of the holding capacity was actually holding salt. The production capacity of the salt works is about 14.5 million tons theoretical production capacity, and the design capacity of the stockpiles is approximately 6.7 million tons. That is 46% of the production capacity. The actual salt on stockpile compared with the production capacity is 1.3 million, compared with 14.5 is about 9%. What does it mean? When we are processing the salt, when we are washing the salt, then then the salt and the washing brine needs to be separated before the salt gets into the market. And the first stage is to let the brine drip off on these drip-off belts. And you can see that at the end of such a drip-off belt, the salt is still very wet and the brine is still in the salt. You can see it here at the bottom, here at the bottom of this stockpile. You can see the brine flowing from the salt stockpile out. Means still the dewatering process is taking place. This graph shows how the dewatering is taking place from approximately 10% residual moisture after the drip-off belt over a period of about 12 to 16 weeks. The humidity reaches 1.5%, and that is what actually the buyers of the salt want to see. The salt should be as dry as possible because they want to buy the salt and not the water. Here are some calculations about what does it mean if the salt is sold, supplied to the buyers, and if it is not yet sufficiently dry. What we want to see is that the magnesium content in the salt actually supplied is less than 0.02%, and because of the content of magnesium in the seawater, which is used to wash the salt, we have some residuum, and we see that we would require about 300 liters of seawater per ton of salt to wash it sufficiently to the level that is required, and that of course leads to salt losses of 10%. Or in other words, when the Australian salt works have a production capacity of 14 million tons of salt, this is a loss of 1.5 million tons of salt per annum. What are the consequences? The consequences are that if the salt holding is only 9% of the production capacity, and the stockpiles require perhaps 3 months to get the salt down to the humidity that is required by the market, then we actually have a lack of 2 months salt production. Okay? The other important point, I was showing you that there was this cyclone, and the cyclone has damaged the salt works. The solar salt works are natural production facility, and anything can happen in the nature. Cyclones can happen, and so on. So solar salt works rely on sufficient stock to be actually able to overcome these setbacks and supply salt continuously. So if we have 9% of salt on the stockpile, what can we say? We see that salt is being sold before it is ready, before it is actually dry enough to be supplied to the market. What does it mean? It means that there is a shortage. There is a shortage, not of all the salt. Salt is everywhere. If somebody needs salt, he can buy it here and there. It's not a problem. The problem is that the caustic chlorine industry, particularly the industry that works today with membrane cells, require high quality salt. Last year at the symposium of Flemion, Sahi Glass in Zurich, I gave a presentation on the importance of salt purity. And I gave, the presentation is published at our website and on YouTube, and it shows that there are very substantial differences between economy of salt and brine, and not only of the brine purification, but also of several downstream units, and the differences are due to impurities in salt. So when we talk about solar salt, we talk about high quality salt of membrane cells. And because this Australian salt works are producing such salt, they are producing excellent salt, best salt in the world, and we can see here that there is a shortage. The total world production of salt is approximately 260 million tons per year, and out of that, 100 million tons is solar salt, rock salt and brines. And when I speak about brines, then this is also a source of vacuum salt, north of Europe, north of America, where there is insufficient insulation. The consumption of salt, we can see that the major user of salt in the world is the chemical industry. And out of that, the caustic chlorine industry is the most important user. Soda ash, of course, also. Food, de-icing, and other uses are less important and also less demanding as far as the salt quality is concerned. Now, let's take a look at where salt is being produced and how it is being traded. Let's start with Australia, where we have, we said this is the major world producer and exporter of salt. It's exporting salt to Asia-Pacific region. It's also exporting to the United States and to Africa and so on, to the Middle East. These streams are less important. Another major exporter of salt, producer and exporter of salt, is Mexico. And Mexico is exporting about 7 to 8 million tons of salt per annum, mainly to Japan and from the island where the salt is stored. It is also supplied to some other areas in the Asia-Pacific, but major amount of salt goes to Japan. The third largest producer of salt for export and for trading in the world is Chile. This is the saltworks Punta del Lobo. It's a geologically very interesting mine. It's an old, very old dry lake with a thick layer of salt. The salt is the purer, the deeper you get. It is being produced by explosion mining, and there, of course, for every 100,000 tons of the good quality salt at the bottom, you have to produce and sell 1 million tons of salt on the upper layers. So most of this Punta del Lobo salt goes to the United States for de-icing, and only relatively small quantity is high quality industrial salt, and it is being exported. India is producing altogether about 15 up to about 20 million tons of salt per annum, and is exporting small quantities, relatively small quantities, 1 million tons, 2 million tons to the surrounding countries. The major salt producer is China, but China is not a salt exporter of any size. On the contrary, China is importing salt. The other salt producers, the total amount of salt that is being traded is only about 50, 60, 70 million tons of salt, but that is about 20-25% of the total. A lot of that is a trade across borders between Germany and Holland, between Canada and the United States, and so on and so on. Here are some figures about the importers of salt in the Asia-Pacific region. You can see that the development of the past about 12, 13 years is it is variable. Yes, there are changes from year to year, but the overall, let's say, growth is in the order of 3.7% a year. What we can see here also is the knick. The knick in the Japanese imports is similar to the knick that we have seen in a number of the presentations before, between the year 2008, 2009, and of course has to do with the recession. Japan was hit hard, the other countries much less as far as the salt is concerned. The overall development of the salt trades and imports shown here with an average growth rate of about 3.4% per annum. Salt prices have been increasing. traditionally, the salt prices, these are delivered salt prices, FOB salt prices from Australia have been reported to be around $18 per ton on FOB basis for many, many years, constant, and they, of course, correspond with the $30 delivered prices. That means that the cost of transport, we have very large ships, it's Handymax and Panamax vessels, works out traditionally at about, let's say, 12 up to perhaps $15 per ton. But this has changed in the year 2005, 2006, and started growing, and since about 2009, the delivered prices in Asia Pacific have been reported around between $50 and $60. 60 is perhaps a little bit too much. There are some indications that the latest prices in the past year perhaps have gone down to 50. This would be perhaps the target today. On the other hand, and again in line with the various presentations that we have seen before, the prices of salt in the United States have remained very, very steady, again improving the competitiveness of the US industry. Here are some prices reported in Japan, Korea, and China. It's interesting to see that the highest prices are being demanded by the local salt producers in China. Now, of course, salt, particularly industrial salt, is a very cheap commodity, and there the logistics are very important. We had some presentation on logistics here. With tankers, we didn't hear much about transport of salt in the bulk carriers, Panamax, Handymax. But one would think that the price development, the delivered price of salt would be very much dependent on this curve. But if you take a look at the comparative, this is not quite in scale, the comparative development of the delivered prices of salt, then you see that there isn't much correlation. That has, of course, reasons, contractual, and several companies that export salt and trade with salt do that with their own ships and so on. Okay, what is the salt supply situation in other regions? The Indian, there are several projects in India. Indian salt is generally not up to the Australian standard. The Australian standard is 0.04% calcium, 0.02% magnesium, maximum 0.12% of sulfate, and less than 0.02% of insolubles. The calcium-magnesium ratio must be more than 2, at least 2, and the humidity for traded salt should be well below 2%. So the Australian standard, it's not really a standard, but this is what the Australian salt producers are guaranteeing when they are signing contracts. So it's being called for convenience an Australian standard. In India, the salt prices have gone up tremendously. You see 200 to 800 tons, that's a rupee per tons. That's a very, very important increase. The South African stockpiles over the past few years we have also seen to be depleted. They can supply what they need to supply, but that is certainly not a surplus. And the South African salt is very good. The Mexican salt production is very steady. It all goes to Japan, and there are problems with environmental people there, and that capacity is not likely to be expanded. The Chilean salt I have already mentioned. Only a small portion of that salt is acceptable to the chlor-alkali industry. And Brazil also is a possible additional producer of high-quality salt in some, not very many, selected salt works, but it is far away from the Asia-Pacific region and could only be taken into consideration for Europe and for the United States. So, conclusion, we don't have enough high-quality salt, and the shortage is likely to accentuate when the present economic slowdown comes to an end and the high growth rates in the Asia-Pacific region are re-established. Now, what is the remedy to this situation? The remedy options are compensate shortage with poor quality salt. This is not desirable because the impurities in the salt, they are harmful to the caustic chlorine industry. There are some very, very cheap salt sources available. On average, perhaps $10 per ton, maximum about 30. But when you take the brine treatment into consideration, then the situation looks quite different. And the best quality and cheap quality salts would give you a price of about $10 per ton, on average about 25, but as high as 50. So we cannot speak about, we cannot speak in general terms. We cannot say salt world price is that and that much. It depends on two benefactors. Remedy option number 2, compensate shortage with vacuum salt. Now, what does it mean, vacuum salt? Vacuum salt is a thermally heated brine evaporated through thermal energy or through electrical energy and crystallizing salt. Salt is expensive because the plants are expensive and the processing expensive. Most of the salt plants, the evaporating plants, are not energy efficient. Look at this. There have been about 110 plants evaluated on the prime energy consumption. You can see these 3 plants here. They are Swiss salt works that require only about 200 altogether. I mean, the evaporator itself only about 150 kilowatt per ton of salt, altogether with the whole plant and pumps and lights and so on, perhaps 200. But most of the vacuum salt works in the world require much more energy. Look, 1,000 kilowatt, 1,200 kilowatt per ton of salt. It's an expensive alternative requiring a lot of energy. So the vacuum salt production is mostly energy inefficient. Existing plants operating today. 1 ton of carbon dioxide per ton of salt may be produced when the energy is produced from black coal. Burning black coal causes pollution if the fumes are not properly purified, washed. And the carbon dioxide in the atmosphere causes global warming and climatic change. Climatic change can be illustrated, well, pollution can be illustrated with this picture, and climatic change can be illustrated with this famous picture of the Hurricane Katrina. And that's how it looked like. It is just awful. The option number 3 is to compensate shortage with additional high-quality solar salt production capacities. In my opinion, this is the highly desirable option. The high-quality solar salt is inexpensive. The operating cost, the production cost of salt, solar salt, is only about $4 or $5 per ton. This is the cost of maintenance of the ponds, the cost of pumping of the brine, cost of harvesting. Salt movement, very low production cost. Solar salt production employs renewable energy most efficiently. We have done a theoretical calculation, theoretical and practical calculation about the efficiency of absorption of solar energy in solar salt works. And it's a simple calculation. How many kilocalories does it need to evaporate so and so much water? And if you have 3.5% of sodium chloride in the seawater, you can calculate how much solar energy or energy has been actually used to crystallize 1 ton of salt. And with this calculation, we came up with a figure of approximately 48–49% conversion efficiency of insolation. Insolation is the energy, it is the radiation, the solar radiation that actually reaches the ground. There is some absorption in the atmosphere and in the clouds and so on and so on. But what actually reaches the ground is about 40, is insolation, and 48–49% of this insolation is being directly converted into evaporation, crystallization, and production of marketable product. There is no transmission. There is no conversion of direct current into alternate current. There are no transmission lines. There is no transformation. There is no efficiency of electric motors, nothing. Directly from the energy that enters into marketable product. Solar salt works are the most efficient converters of solar energy into a marketable product in existence on Earth. Now, this is the distribution of solar energy, of insolation on Earth. Now, I'm sorry that the contours of the continents are not very well visible in this picture, but you can recognize South America here. You can recognize Africa. You can recognize India and China, the Gulf of Guam. You can recognize Australia, and this is the Western Australia where the solar salt works are located. So what does it mean? It would make, and it does make, a lot of sense to produce salt in Australia, to produce salt in Baja California, in Mexico, to produce salt in India, very favorable. But if that is not enough, for various reasons, Australia environmentalists managed to kill the Yanari project that that was designed to produce 10 million tons of high-quality solar salt for caustic chlorine industry for incredible reasons. If that is not possible to be done here, then where should we do it? Where should we produce high-quality solar salt? In India, we have problems, particularly with flat shore. It's a long time to get into the deep waters to load large ships. In the Middle East, the problem is that there is no suitable ground there. It's all sand with water. It dissipates. Similar situation is on the west coast of Northern Africa, mostly sand. There are some spots there that are suitable to produce salt. South Africa, not quite South African Republic, but perhaps a little bit further north. And really, that's it. China, in the 60s, 70s, China embarked on improving the efficiency of their solar salt works. The solar salt works are very, very old. They were established many, many hundred, if not thousand years ago. And they have decided to protect their crystallizers against the rain with plastic sheets, plastic rolls. When it should be raining, then they pull these plastic sheets over the brine. That, of course, requires many workers, and the workers actually live in the salt works. Here is the salt work, here are the crystallizing ponds, and here the workers live. They have perhaps 3 by 3 meters house where the whole family lives, with a nail on the wall, put their clothes, and roll up their mattresses and sleep there, and then go to work in the morning. It is not conceivable that this way of living can be sustained for many years. There is another reason for the impossibility to invest in solar salt works in China. Look at this. Compare the productivity of the Australian salt works in terms of tons of produced salt per square kilometer. You see 31, 29, 40, 38, and 7.5 is the efficiency or the productivity of the salt works in China. Consequently, these are the largest 2 solar salt works in Tianjin. This is Tianjin, and this is the Teta development area. This is the Hangu Salt Works and Dangu Salt Works, and you can see that already now they are being eaten up. They are being, the areas being taken away here for coal imports and storage, and here for industrial parks. And this is how these industrial parks look like. There are remains of solar salt works here already being converted or being liquidated, and here new chemical plants have already come up, have been built and are in operation. There is very little chance that the Gulf of Bohai will be maintained as a production site for solar salt. What is the alternative for China to produce their salt? Well, they produce vacuum salt. They burn coal and discharge 1 ton of carbon dioxide per ton of vacuum salt that they produce. Solar salt exports could fill the gap. I mentioned these items already. The conclusion is that, the recommendation is that we build more new solar salt works using modern technology, and I'm glad to say that Solar Partners are part of this. We are active, as you can see, hands-on in some places. That's me. In some places in the world, developing new solar salt works. We think that it is the future. It's difficult, it is slow, but it is happening. We supply technology for high quality salt production, purification. This is a plant in Spain. This is the largest plant that we have built. The diameter of the vessel is 10 meters, and the capacity is the capacity of this plant, if operating with solar salt, would be about 500 tons per hour. And this is our advertisement. We are turning salt into gold. So if you want to turn your salt into gold, please come to us and talk to us. We'll be glad. Thank you very much for your kind attention, and I wish you a good end of this symposium. Thank you very much.
Thank you very much, Mr. Sedeli. Certainly, I think you deserve a prize for the most interesting photographs of the conference. We hope very much that we'll see you again in next year, same time probably next year, not necessarily the same place, we don't know, but remember on this form you can give us your ideas about where you'd like to see it for next year. We'll take that into consideration. So once again, thank you all, delegates, speakers, for all your efforts and support, and hope to see you all next year.